Hello everybody, welcome back to Math 2413, more on math. Today we're going to talk about Chapter 2, Section 5, homeworks. Here's the note. If you're taking the limit and it gives you 0 over 0 when x equals c, then rewrite your equation, simplify it, and then try it again. Here's the example. Question number 1 in our homework. Find the limit as x approaches 9 of x minus 9 divided by a radical x plus 7 minus 4. Okay. The limit as x approaches 9 of x minus 9 radical x plus 7 minus 4. If we plug in 9 into these, then you'll see we get 0. 9 plus 7 is 16. You get 0 over 0. So, when you have radicals, then multiply by its conjugate. So in this case, we have the limit as x approaches 9, x minus 9, radical x plus 7 minus 4. So we multiply. Here's the radical. X plus 7 plus 4. Remember, the conjugate is simply just change the sign in the middle. We need to do it top and bottom, because we're not changing the equation, just changing the way it looks. Alright, so let's see what happens here. Let's leave the top alone for right now. Now, radical x plus 7 times radical x plus 7 is x plus 7. Radical x plus 7 times 4 is positive, so radical 4 times radical x plus 7. Negative times positive is negative. 4 times radicals x plus 7. And then negative times positive is negative. 4 times 4 is 16. Simplify this, we get those two are gone. We have x minus 9, x plus 7 plus 4. So all I have left on the bottom is x plus 7 minus 16. X plus 7 minus 16 equals negative 9. So we have x minus 9, x plus 7 plus 4 over x minus 9. So now, when we take the limit as x approaches 9 of, we get 9 plus 7 plus 4, which is 16 plus 4. 4 plus 4 equals 8. So this first value is 8. So it makes it much easier. If you ever have a radical and it gives you 0 over 0, when you plug in the value, then simplify it. All right, the next one's. Suppose the limit of f of x when x approaches 8 equals 14, and limit of g of x as x approaches 8 is negative 9. Now we can look at these rules. Find the limit of f of x, g of x. That's the product rule. Since the limit of f of x when x approaches 8 is 14, and the limit of g of x is negative 9, that means we multiply them together. Answer is negative 126. This one, it's 8 times f times g. Well, we have f times g already, so this one is 8 times 14 times negative 9. So basically, this already is negative 126 times 8 is negative 1008. Okay, f of x is 14 plus 7 times g of x times negative 9. So it's 14 minus 63 equals negative 49. All right, last one. F of x is 14 over 14 minus negative 9. This becomes a positive. 14 over 23. Prime number, so the answer is 14 over 23. Question number 3. State whether the function graphed is continuous on the interval from negative 1 to 3. Is it continuous there? If not, where does it fail to meet continuity? There's no discontinuities, there's no open circles at the bounds. So the function is not, it is continuous. It is continuous. All right, next page. Use the function and the accompanying figure to answer the following questions. Is f defined at x equals 2? At x equals 2. Is it defined? No. Because there's nowhere here when x equals 2. Is f continuous at x equals 2? In other words, by continuity, can you go from beginning to the end without lifting your pen? No, because it's an open circle, so no. Use the graph to answer the question about discontinuity. Select the correct description of the continuity of f of x at x equals 1. Right here, x equals 1. There is a discontinuity that can be removed because left and right limits differ. That doesn't make sense. The discontinuity that there is a discontinuity that cannot be removed. No. You're not defining it because there's two different values. Nope. There's a discontinuity that cannot be, it cannot be removed because this one exists and that one's approaching that value. Number 6. At what points of the function x plus 1 over that is it continuous? So by continuity, whenever you have rational equations, fractions, the only place it's not continuous is wherever the denominator is equal to 0. So let's factor it. Since x is x and x, the second sign's a plus, which means both signs are the same. They're both the first sign, they're both minus. What times what is 5? When you add them, you get 6. 5 and 1. So here, now I set both of those equal to 0. I get, these are the points of discontinuity. These two make the bottom equal to 0. So describe the set of x values the function is continuous. So the function is continuous from negative infinity to 1, from 1 to 5, and then from 5 to positive infinity. Remember, they're parentheses, so they're not included. So that's the answer for that. Determine the points at which the given function is continuous. For radicals, remember the graph of radicals looks like this. So they have a starting point. It's wherever the inside of the radical is equal to 0. So that's the smallest it can be, is at 0. Subtract 9 from both sides and divide by 3. So with this one states that from negative 3, if I put anything to the right of that, it's going to be a valid answer. So negative 3 to infinity. Because it's a bracket, because I can include negative 3. If I put negative 3, it becomes 0. Square root of 0 is 0. It's a valid answer. At which point is the function continuous? It's a 1/3, so what this equation looks like is this. Unlike the radical, the square root, the cube root, the graph of the cube root looks like this. The answers can be positive, negative, or 0. So because of that, cube root functions are continuous throughout the entire realm of the real numbers. Next one. Find the following limit. Is the function continuous at the points being approached? Alright, it's like this. So we have secant. Remember, secant is 1 over cosine, because the first letters can't be the same. So let's see what we have inside here. Y secant squared let's see here. Secant minus tangent. Let's look at our identities. From the Pythagorean Theorem, we know that the cosine squared plus sine squared equals 1. That's the unit circle. So that's the first one. That's the identity. So what if we divide everybody by cosine squared? Cosine over sine, cosine is 1. Sine over cosine is tangent. 1 over cosine is secant. So secant squared minus tangent squared is 1. Why is that important? Because in our equation, we have secant squared minus tangent squared. Oh, but there's a y in front of it. So we have, so that doesn't work. Great. So the limit as y approaches 1 of secant of y 1 over cosine squared y sine squared over cosine squared minus 1. So this one is y over x squared. So 1 minus sine squared. So we have secant of y minus sine squared y minus cosine squared all over cosine squared factor out the negative, so I have sine squared plus cosine squared over cosine squared. Sine squared plus cosine squared is 1. Now, when y approaches 1, so it's secant of 0, which is 1 over cosine of 0. Cosine of 0 is 1, so the answer is 1. Is the function continuous at this point? Yes. Now, define g of 6 by following the function. So that is continuous at 6. Okay, so we have 7 times 6 squared minus 252. 7 times 6 minus 42. 7 times 36. 42 minus 42. 252 minus 252, 42. 42 minus 42, we got 0 over 0. Okay, remember I said if you have 0 over 0, because what we did, we took the limit as x approaches 6. We just plugged 6 in there. So let's see what can happen here. This one is 2, 5, 9. We're looking at 2, 5, 10. We're finding this as x approaches 6. 7x squared minus 252. 7x minus 42. They both have a 7 in common. So if I factor out a 7, I got x squared. Fact 252 divided by 7 is 36. Take out the 7 out of the bottom. So the 7's cancel. X squared minus 36 is a perfect square, so it's x plus 6, x minus 6. X minus 6 cancels, so 6 plus 6 equals 12. Number 11. Prove that f of x is continuous at c if and only if the limit x plus c plus h is equal to f of c when h is 0. Okay, first assume that f is continuous at c. Find the definition of continuity. If it's continuous, okay, f of c has to exist. If it's continuous, the limit has to exist. And if it exists, that means the limit has to exist. Then when we take the limit as x approaches c, that has to exist. These two are roughly the same. What this one really means is I take the limit as x approaches c from the left has to equal the same value as I approach it from the right, which is the limit at c. So it's all the above. If limit of f of x is equal to f of c, how can this be used to show that the limit of f of c plus h as h goes to 0 is f of c? Okay, define h equal to x minus c. Yes, so far so good, because if you did h is x minus c, then c plus x minus c is f of x. And then so that would be 1. Since h approaches 0, the statement cannot be, I guess it can be evaluated. Define h as x plus c. No. Because if you put h as x plus c, then we'll have x plus 2c. No. Cannot be shown. I can't. So in this one is define h as x minus c. You go to the definition of continuity. Now assume that the limit as h approaches 0 of f of x plus c equals f of c. Can h be defined so that f of c and the limit of f of x as x approaches c exist? Yeah, that's exactly how you're supposed to do it. That's what I'm saying. If this is to show that it works, this is how it's going to work. Does the statement limit of f of x as x approaches c equal to f of c imply that f of x is continuous? Of course. That's a necessary condition. And number 12. Use the intermediate value theorem to determine whether the following equation has a solution or not. If so, then use a graphing calculator or computer grapher to solve the equation. x3 9x minus 4 equals 0. Select the correct choice below. So we first have to look at the intermediate value theorem. All right, what is the intermediate value theorem? The intermediate value theorem states that if there's a value between the functions, so one of them is, if we pick a value, say 1, and the answer there is positive, we pick a negative 1 and it's negative, that means the graph has to go somewhere where some point between -1 and 1, the c value has to make the function equal 0. So whenever it changes signs, it has to be some point that crosses the x-axis. Now we could try to look at this and doing Pascal's rule of signs or the synthetic division process we learn in algebra. But what's going to happen here is it's going to give us some weird numbers. If you use Desmos, if you go to desmos.com and just go in as a guest, and in the box in the top right hand corner up here, type this: y equals x cubed minus 9x minus 4, and press enter. You're going to see something like that. It's going to have this. The highest exponent tells us that we have at most 3 x-intercepts. It tells us we're going to have 2 vertices at most. All right. So now in Desmos, once you get this graph and you just put your cursor here on top of that, what you'll get is a value that's something like, it'll say this. That's that point. That point will give you and this point will give you something like that. But the problem is it wants 4 decimal places. And Desmos only gives you 3. At least I don't know there's a way you can increase that. So other than trial and error, I don't know. Usually, if you know how to use your calculator or your cell phone, figure out better ways of solving this. If you find these values on Desmos, I'll give you the credit for it. All right. Good luck, everybody.